So student, today's point is free charges and bound charges. If we consider a copper atom in this 29 electrons are present, then electronic configuration will be 2, 8, 8, 8 and 3. Then electronic configuration structure will be like this. In first cell there are 2 electrons. In second orbit there are 8 electrons. In third orbit also 8 electrons. In fourth orbit there are also 8 electrons, and in fifth orbit there are only 3 electrons, 1, 2 and 3. These 3 electrons are in the outermost orbit of the copper atom, and these 3 electrons will be loosely bound, or these 3 electrons are loosely bound with this nucleus. So these electrons, if we apply an electric field to this atom, then these electrons can easily detach and move freely inside the metal, and when electric field is applied they move in a direction opposite to the direction of the applied electric field. These charges are called as free charges. आता न्यूक्लियसच्या बाबतीत बघा, इथं काय पॉझिटिव्हली चार्ज न्यूक्लियस प्रोटॉन्स आर प्रेझेंट इन द न्यूक्लियस अँड इनरमोस्ट shells electrons in the innermost cells are tightly bound with the positively charged nucleus, and they are not a mobile electrons. These electrons or these charges are called as bound charges. Bound charges. The electrons which in the outermost orbit of the atom, which are loosely bound with the nucleus, these charges or electrons can easily detach from the nucleus and move freely inside the metal, and when external electric field is applied to them, they move in a direction opposite to the direction of the applied electric field. These charges are called as free charges. And nucleus consists of the positive ions, and the electrons of the inner shell, this inner shell, remain held in their fixed position. These immobile charges are called as bound charges. Next point is dielectrics. Dielectrics are the materials which can be used to store the electrical energy. To store the electrical energy. When such substances are placed in an external field, their positive and negative charges get displaced in the opposite direction, and the molecules develop a net dipole moment. Suppose this is the dielectric. This is suppose non-polar dielectric. Positive, negative, negative. If we apply electric field to this dielectric, then their positive and negative charges get separated. Suppose this is the positive, negative, positive, negative, positive, negative, positive, positive, negative. Then these molecules develop a net dipole moment, and this is called as a electric polarization, and such materials are called as a dielectrics. This shows the in presence of the electric field, in absence of the electric field. Suppose glass, wax, water, wood, mica, rubber, stone, plastic, etc. are the examples of the dielectrics. Dielectrics can be classified into polar dielectrics, and second is non-polar dielectrics. Non-polar dielectrics. Then polar dielectrics. Polar dielectrics. Molecules in which the center of mass of positive charges does not coincide with the center of mass of negative charges. Center of mass of positive charges and center of mass of negative charges does not coincide with each other. Such molecules are called as polar molecules. Examples for this are HCl, water, alcohol, NH3, ammonia, etc. So, positive charge and negative charge are separated in that molecule. That means center of mass of positive charges and center of mass of negative charges does not coincide with each other. Such materials are called as polar dielectrics or polar molecules. Suppose this is the HCl molecule. This is Cl molecule. And this is hydrogen molecule. Then they have the dipole moment from chlorine to hydrogen, that means negative to positive. In case of water molecule, this is the hydrogen, this is the hydrogen, and this is the oxygen. Then dipole moment is in this direction. The next point is non-polar molecules. Non-polar dielectrics. A molecule in which the center of mass of positive charges coincides with the center of mass of negative charges are called as a non-polar dielectrics. That means structure for that positive, negative, like that. Therefore they have the zero dipole moment. Example for the non-polar molecules are hydrogen, nitrogen, oxygen, carbon dioxide, benzene, methane, etc. These are the examples of the non-polar dielectrics. In hydrogen atom or hydrogen molecule, center of mass of positive charge and center of mass of negative charges gets coincide with each other. Therefore, they don't have the dipole moment. They have a zero dipole moment. The next point is polarization of a non-polar dielectric in an external electric field. So what is meant by a non-polar dielectric? In which the center of mass of positive charges and center of mass of negative charges gets coincide. These molecules are called as a non-polar molecules. When this non-polar molecule is placed in an external electric field, then suppose this is the structure for the non-polar molecule, positive, negative. When we place this non-polar molecule in an external electric field, their positive center of mass of negative charges and center of mass of positive charges get displaced in the opposite direction, or positive charges and negative charges are separated from each other, then this molecule will have a dipole moment. If we apply an electric field to this, then we will get a structure like that: negative positive, negative positive, negative positive, negative positive. That means these non-polar molecules become a polar and will show a net dipole moment. That is, this is in the absence of the electric field, absence of the electric field, and this situation will be in the presence of the electric field. Presence of the electric field. Next point is polarization of a polar dielectric in an external electric field. Polarization of a polar dielectric. Polar molecules means the center of the positive charges and center of mass of the positive charges and center of mass of the negative charges does not coincide. Then these molecules are called as polar molecules or polar dielectric. These polar molecules have a tiny permanent dipole moments. Tiny permanent dipole moments. These polar molecules will have a tiny permanent dipole moments, and these dipole moments are randomly oriented. Suppose this is the structure for the polar molecule, negative positive. These dipole moments are randomly oriented, therefore net dipole moment of the molecule will be equal to 0. When an external electric field is applied to this molecule, then when an external electric field is applied to this molecule, then the dipole moments of the different molecules tends to align with the fields. Then we will get a structure like this: negative, negative, positive, negative, positive. That means these dipole moments are aligned. Electric field is applied, then this molecule will show a dipole moment. Hence, such a dielectric is polarized in presence of electric field. In presence of the electric field, dipole moment per unit volume is called as a polarization. Dipole moment per unit volume is called as a polarization. And this P bar is equal to psi E into E bar, where psi E is the electric susceptibility of dielectric, and E bar is the electric field, external electric field. For vacuum, psi E is equal to 0. Next point is reduction of electric field. Reduction of electric field due to polarization of dielectric. Polarization of dielectric. Consider a rectangular dielectric slab. Suppose this is the rectangular dielectric slab placed in an uniform electric field E. This is the uniform electric field E. This is the polar dielectric, negative positive. When we apply a uniform electric field to this dielectric slab, this electric field produces a slight rearrangement of the charges within the atoms, and this field aligns the atoms with the field or in the direction of the field. Suppose this is the metallic plate, this is the positive metal plate, this is the dielectric slab placed in the electric field, and this is the negative metal plate. Then the negative charges will induced at the positive plate side and positive charges are induced at the negative plate side. That means here electric field is present, that is E0, and this electric field is called as a induced electric field or polarization field. This E0 will oppose a external electric field. The net electric field is given by E dash is equal to E minus E0, that is in magnitude. Then we get a structure like this. This is the positive plate, this is the net electric field, this is the negative plate. This induced dipole moment disappears when the field is removed.